I'm Dr. M. Manikam, Assistant Professor, Department of Physics, Dr. SNS Rajalakshmi, College of Arts and Science, Coimbatore. So today in this video, we will discuss about a transistor, a common base configuration details we will discuss. So this is a lecture series video. So continuously we are talking about the basic electronics. Today we will discuss about transistor common base configuration. So let's go into the video. So bipolar transistor, simply can say it is BJT. So which means it is a three-terminal semiconductor device. So it has three terminals. That is the emitter, base, collector. So simply can say it is CBE. So it is usually it is used mainly for amplification and switching purpose. We are using this transistor. So this is the two types of transistors, and one is the NPN transistor, another one is PNP transistor. So the symbol of NPN transistor. The next one is the symbol of PNP transistor. So the arrow mark in the emitter terminal indicates the current flow directions. So for NPN transistor, the current is coming out from the emitter. Then in PNP transistor, the current is supplying through the current flow through the emitter and reaches the base and then come out from the collector terminals. So this is the difference between NPN and PNP transistors. So inside the PNP and NPN transistor, already we have discussed in our previous videos. So NPN transistor and PNP transistors are back-to-back connected PN junction diodes. Two diodes we are used here. So NPN means the both are from the base to emitter one diode and base to collector another diode is connected like this. So from PNP transistor, so it is from collector to base, then emitter to base, two diodes are connected. So transistors, there are three different types of modes or configuration is there. So one is common base configuration, another one is common emitter configuration, then third one is common collector configuration. So one by one we will discuss. So first one we will discuss about the common base configuration. So common base configuration, that is here in this configuration or connection. So emitter is the input terminal and collector is the output terminal. So here base is used as the common one. So this is common for input and outputs. So you can also call it as the grounded base configuration. Another name, that is CB amplifier. So mainly transistor used for amplification purpose. So we can call it as CB, common base amplifier. We can call it is. So this is the circuit diagram for NPN transistor, which is connected in common base configuration. So here, we are used to two power supplies VBE, so which is connected in between the base and emitter. Then VCB, which is connected in between the collector and base. So current flow through the starting from VCB, so positive is connected with the collector and negative is connected with the base, and the base is connected with the positive of VBE, then negative terminal of the battery VBE is connected with the emitter. So the current is flowing through collector and reaches the base and it come out from the emitter. So through the input current is flowing through collector and base, and current IE, that is output current, is coming out from the emitter terminal. So this is the common base configuration. The second one is NPN transistor connection. So first one is a symbolic representation, then second one is NPN transistor. So there are two type of junctions is there. So NPN, that is JE one junction, and JC is the another junction. So junction nearby collector, then junction near emitter. So there are two junction is there. So the input current is flowing through collector and base and reaches the emitter, come out from the emitter. This is the common base configuration. So internally, what will happen? So how the electrons and holes are moving in the common base collector configuration, we'll discuss. So here, so basically, emitter base collector is there. So this is the NPN transistor. In between emitter and base, there is a junction. So that is a small depletion layer is formed in between the base and emitter. Then in between base and collector, a large depletion layer is formed in between the base and collector, because so there are based on the doping percentage or doping amount of doping, so depletion layer will be formed. So the one p-type semiconductor material is sandwiched between the two n-type semiconductor materials. So emitter is connected with the battery, that is negative terminal of the battery, and collector is connected with the positive terminal of the another battery. So both are connected in the base. So common two batteries are connected with the base. That base is connected in between the emitter and collector. So here, so suppose in VEE, that is in the first emitter battery, so that is it's connected to the negative. So in emitter terminal, so majority charge carriers are free electrons. So if you are supplying negative ions through the emitter, so it will repel. So the electrons are moving towards the junction, that is BE depletion. I mean, in between base and emitter, the electrons are moving towards the junction. Then here collector side, that is positive is connected to the collector. So what will happen? So negative positive ions is applied to the collector. Then already majority charge carriers are in n-type semiconductor material, that is electrons. So it will attracted by the positive ions. So the electrons are moving towards the positive ions. So then the base, through the base, so in between the this side, in this side, this battery side, this. So these electrons will move towards the NP junction, I mean base emitter junction. Then after the reaching the base emitter junction, so the small region, so base is the small surface area is there. So emitter and collector has the large surface areas. So then after reaching the electron from the emitter base, so from the emitter the electrons moving towards the junction and reaches the base, and again the base electrons, I mean in between that there is holes, majority charge carriers are holes in the base. So both are recombined and reaches the collector. So the by applying the positive ions through the collector, so it will attract the electrons. So easily it will transfer from base to then collector. So the electrons are moving from emitter to collector through the base. So finally the current is generated in the collector, so it reaches the collector. So this is the inside the configuration of NPN transistor. So after so this is the what we have discussed. Input applied in between the emitter and base, then output is taken between the collector and base. So base terminal common to both in input and output, already we have discussed. So the supply voltages are VBE and VCB, so that is base to emitter voltage and collector to base voltages, that is the we have discussed. So there are two types of configurations. I mean, characteristics is the input characteristics and output characteristics is there. So this is the diagram for input characteristics of common base configuration. So suppose we are drawing the graph between the voltage BE voltage versus the IE current, emitter current. So here VCB is the constant. So if you are fixed, VCB is the 0 volt means initially. So while increasing the voltage between the base and emitter battery power supply, increased voltage is increased gradually. So what will happen after reaching the germanium, or if you are using germanium means it will take 0.3 volt, or if you are using a silicon means it will take 0.7 volt to breakdown, so breakdown voltage. So if you are supplying the here in this case we are using a silicon material for NPN transistors. So we are supplying voltage, VB voltage is increased, so it will gradually increase and reaches the maximum point of emitter current. So again we are increasing the VCB voltage, the voltage between the collector and base, that is 8 volt, 18 volt, like that. Where if you are increasing means, so it will moving or shifted towards left hand side. So the breakdown voltage will decreases while increasing the VCB voltages. This is the conclusion for input characteristics. So for output characteristics, there are three types of operation modes is there in the BJT, that is cutoff mode, saturation mode and active mode. So this is the graph for output characteristics of common base configuration. So here IE, I mean IE current, that is a constant one. Here if you are increasing the we are plotting the graph between VCB common base versus the IC collector current, that is the output current we are following. So if you are increasing the VCB voltage gradually, so this is the saturation region. In saturation region, so it is gradually increasing and reaches the saturation point. And again if you are increasing the VCB voltage, then at a constant current, that is VCB VB, if it is VB is constant means the IE current. So basically if you are fixing the IE current, that is 0 milliampere for first stage, that is the cutoff region. So if you are not supplying any current through collector means, so it is working the common base configuration, the cutoff region. So if you are increasing the current emitter current like 1 milliampere, 2, 3, 4 up to 6 milliampere, if you are increasing, so in saturation region it is gradually so suddenly increases and reaches the saturation point. So in this active region, so if you are increasing the VCB voltage gradually, so then IE current, so different IE currents, I mean emitter currents we are reaching. So for different IE current we are measuring recorded the VCB voltage versus IC, I mean collector current we have measured. So in the active region, so almost the same current, collector current for different emitter current values. So from this graph we have concluded that again we'll discuss the biasing in common base configuration, that is base emitter junction, that is forward biased. Then collector base junction, in between collector and base junction, that is working in the reverse biased. So this biasing is same for both NPN and PNP transistors. Then configuration, so input applied in the emitter, the output is taken from the collector. So as we have discussed before, so a base is common in both NPN and PNP circuits. It is working principle like is same. So for both NPN and PNP working principles are same. So what's the main difference between the NPN PNP is electrons are majority charge carriers in NPN transistor. Then in PNP transistor, holes are majority charge carriers. So this is the difference between the NPN and PNP. So after the output configuration graph, that is the conclusion of that graph is the emitter current is the largest one. So relation between the currents, that is the emitter current IE, that is equal to IB plus IC. So which means the emitter terminal is the input one, then that is equal to IB plus IC. So input current is the emitter current, then output current is collector current. So here the current gain of the common base amplifier, that is the current gain alpha, that is equal to IC by IE. So the value of alpha is less than 1. So because the input voltage is attenuated while performing the common base configuration. So typically its value of current gain alpha is the approximately 0.98. So again we can conclude that after the input and output plots, so common base amplifier attenuates the current. So if suppose we are supplying the 100% of current, means it will, you will get the in the collector current, that is the output current, that is 98% of current only we will get. So this is the conclusion of common base configuration. So the applications of common base amplifier or transistor, that is which is used where we need, so low input impedance is required. Wherever you are need of low input impedance, means we can use the common base configuration or common base amplifier. So we can use it as a voltage amplifier or current buffer, as we can use the current buffer also. So it is not commonly used compared to common emitter and common current. So when compared to so another two types of configuration is there, common emitter and common current. So it is not a common one, so that is a common base. So usually common emitter and common current configurations are generally used. So thank you for watching this video.